In this video, we're going to look at the curve t squared 3t negative t squared, or the path t squared 3t negative t squared, which traces out some curve. And we're going to be looking at the curvature of this path in two different ways. One way we'll be using kind of the standard definition of curvature, which is the norm of the derivative of our unit tangent vector divided by speed. And then in a separate video, we will look at it using this other definition. And this first video will be more of a cautionary tale of why this definition, this first one, is sometimes awful, which you will see. This is my third time making this video because I messed up twice. So let's go ahead and find the curvature using this original formula and see what happens. So first we need to find the unit tangent vector, which is going to be the derivative of x divided by the norm of the derivative, which is another way of saying it's the velocity divided by the norm of velocity. So let's go ahead and start by finding the derivative of x, which is going to be 2t, 3, negative 2t, which seems relatively simple. So you might wonder, why does this get awful? Well, the reason it gets awful is once we look at the speed, or the norm of the derivative, it's not very pretty. We're going to have 2t squared plus 3 squared plus negative 2t squared, which is going to be the square root of 4t squared plus 9 plus another 4t squared, which is the square root of 8t squared plus 9. So when we go ahead and find that unit tangent vector, our unit tangent vector is going to be our original velocity vector, or the derivative of x, divided with each component divided by that speed. So it's going to be 2t over the square root of 8t squared plus 9. We're going to have 3 over the square root of 8t squared plus 9, and then negative 2t over the square root of 8t squared plus 9. And then where this gets really unfortunate is when we realize that we need to find the derivative of this. So what's the derivative of this lovely, lovely formula here? The derivative, well, let's go ahead and do it component by component. We're not going to write that yet. We are well away from writing that. Let's start off by looking at the first component, which is 2t plus square root of 8t squared plus 9. So that derivative of 2t divided by square root of 8t squared plus 9, we're going to need to use the quotient rule. You could probably do this without the quotient rule, but it's one of those where it's going to be more work to do it without than it is to do it with. So we'll take the derivative of the top times the original of the bottom minus the original of the top times the derivative of the bottom. I know the derivative of square root of x is 1 over 2 square root of x, and then I'm going to have some chain rule going on. This is going to be 1 over 2 square root of 8t squared plus 9. And then chain rule, I'm going to multiply by 16t. All of that over square root of 8. Oh, it's going to be square root of 8t squared plus 9 squared, which is just going to be 8t squared plus 9. Now, I want to simplify the numerator a little bit, so I'm going to multiply the numerator and denominator of this fraction by the square root of 8t squared plus 9. My first term is just going to become 2 times 8t squared plus 9 minus this 8t squared plus 9 and that 8t squared plus 9 will cancel. Just we'll have some 2's canceling, so this is just going to be minus 16t squared all over, and then we'll write this as 8t squared plus 9 to the 3 halves. we want to do a little bit more simplification, I'll go ahead and distribute that too to get 16t squared plus 18 minus 16t squared all over 8t squared plus 9, 3/2. And I notice that those 16t squareds cancel, leaving us with 18 over 8t squared plus 9. And it did take me 3 tries to get that derivative correct. So there you go. That wasn't very fun. The good news is that our next derivative isn't as bad. When we look at the derivative of 3 over square root of 8t squared plus 9, this one we're not going to think of as a quotient rule problem. We're going to think of it as a chain rule problem. We're going to think of this as the derivative of 3 times 8t squared plus 9 to the negative 1/2, which is going to be negative 3/2 times 8t squared plus 9 to the negative 3/2. The negative 3/2 and the negative 3/2 might throw you off a little bit, but the only reason they're the same is because we started with a 3 up front, just as a note. And then we're going to go ahead and multiply that by the derivative of the inside, which is 16t. We can do a little bit of simplification. For example, that 2 will reduce with the 16 to give us 8. We're going to get negative 24t over 8t squared plus 9 to the negative 3/2. And yes, there's one more derivative that we need to take. We also need to take the derivative of negative 2t over square root of 8t squared plus 9. But that's just the negative of the first derivative we found. So that's just going to be negative 18 over 8t squared plus 9 to the 3/2. Since I noticed that we have a lot of things in common, I could actually factor out, I can write, in fact, this is what I'll do. I'm going to write the derivative as, and this is just going to make my life so much easier coming up soon, I'm going to write the derivative as 6 over 8t squared plus 9 to the 3/2, because I can factor that out from all of them, and what I'm left with is 3 negative 4t 3 oh, and there's a negative here as well. Don't want to forget that. But what I'm really interested in is I'm interested in the norm of t divided by the norm of x prime of t. Now, what I can do, I'll write this out. This is the norm of 6 times 8t squared plus 9 to the 3/2 times 3 negative 4t negative 3 divided by, we know that the norm of the derivative of x, that is just the square root of 8t squared plus 9 that we've gotten absolutely sick of writing. So what I can do is this right here doesn't look like it, but it's just a scalar. And multiplying by a scalar just multiplies the magnitude by that amount, so I can pull that out front. So I'm really going to write this as 6 over 8t squared plus 9 to the 3/2 times the magnitude of 3 negative 4t negative 3. And then I'm going to write this as 1 over square root of 8t squared plus 9, just so we can see how stuff cancels out. Okay, so I notice I'm going to have 6 8t squared plus 9. That's going to end up just being 8t squared plus 9 squared times the norm of this, which is going to be 9 plus 16t squared plus 9, which is 6 times 8t squared plus 9 squared. This is going to be 18 plus 16t squared. But if we factor out a 2 from that, we realize that we can write this as 6 square root of 2 times square root of 9 plus 8t squared over 8t squared plus 9 squared. And since we have a little bit more cancellation we can do, basically, if we think of this as maybe 4 over 2, we'll notice that we can cancel out one of those, and we just end up with 6 square root of 2 over 8t squared plus 9 to the 3/2. And that, I know, is the right answer, because there's another way to do this, which in this case is much easier. But we should notice that this is a calculation that we can do. It was ugly as anything else, but it was possible. This also shows you how working with the moving frame vectors can get really ugly really fast, and maybe encourages us to maybe look at alternate ways to calculate things like curvature that might not involve finding those moving frame vectors. So there you go. That's it for this video.